Stanford University.
All right, well, welcome to lecture number 14 of CS193P. Today, we are going to go over two related topics. One is core location, which is a framework for specifying locations on the planet, actual, physical latitudes and longitude on Earth. And then MapKit, which is a way of displaying places on Earth. Okay, so these are two very related topics. And so let's jump right in. We're going to have a demo at the end, as usual. So what is core location? So core location is a framework for managing location and heading. All right, so you can imagine that your phone knows where it is to some extent, and we'll talk about what that extent is. And also your phone, if it has a compass in it especially, but even if it's just moving and it can tell the new positions, it can kind of tell your heading, okay? So core location kind of abstracts away the figuring that out and provides API. Core location is not a user interface API, okay? It's object-oriented, but it's not about user interface, it's about your location. The basic object, the most important object, kind of the unit of communication inside core location is called a CL location. CL location has a property on it called coordinate. You can see here. It's read-only, which is important to recognize. And it basically returns the latitude and longitude and has another property called altitude. So you can see SEL location can tell you where you are on the planet, even where you are above the planet Earth. If altitude is negative, by the way, that means you're below sea level. And I say that because sometimes a negative value in these properties for the CL location thing mean this is invalid, but a negative altitude does not mean it's invalid, it means below sea level. Okay, so this is pretty straightforward representation of the local of what a location is. Now, the thing about this though is your phone or your iPad or whatever is not a perfect locating device. It doesn't know exactly where it is on the planet, okay? So there's also a property in CL location called accuracy. There's horizontal accuracy and vertical accuracy. Okay, now the type of this is CL location accuracy, which is a double in the current implementation. But really we compare it against these predefined constants, okay? So there's KCL location accuracy best for navigation. So this is the best possible accuracy. So this is going to use every trick in the device's book. If it has GPS, it's going to use that. It's going to be using cell towers. It's going to use everything it can get its hands on to try and calculate where it is. But as a result, it's going to use a lot of power. So this setting is generally for you've got your phone in your car or you're doing driving navigation or something and your phone is like plugged in, right? Plugged into your cigarette lighter or something. It's got power. That's what this setting is for. Then there's the next level down, which is location accuracy best, which is generally GPS. But, and whether you don't know what's behind these constants, and so that's why I'm kind of being vague about it, because they don't document it, and it's specifically done this way so that as new location finding devices and hardware come out, they can add new constants or improve the performance of these constants or whatever. But best, you can imagine, is probably GPS. Nearest 10 meters might also be GPS. When you start getting into the lesser accuracies like kilometer and 3 kilometer, now you can imagine that the phone might be using things like cell towers and Wi-Fi, okay, to find out where you are. And we'll talk about those in a second. But generally, the more accuracy that you request the system to give you, because you're going to get these location objects by asking the system, where am I? And you're going to specify an accuracy you're interested in, the more battery you're going to use. That's really the highest correlated system resource is battery. Okay, if you ask for high accuracy, you're going to use the battery more. So the device, you give it an accuracy that you want when you ask it, and I'll talk about how to do that in a second, and it's going to do its best. Now, current known ways that it can find out where it is, cellular tower triangulation, so it can find out what cellular towers the phone can see from here. That's a pretty good way to kind of see where you are, generally, pretty low accuracy. There's also Wi-Fi node database lookup, which is kind of cool. There's a big database on the internet you may not have known with maybe not all the Wi-Fi locations in the world, but a whole bunch of Wi-Fi locations all over the world. And your Wi-Fi antenna inside of your device, whether it's an iPad or an iPhone, it can find out, well, what Wi-Fi hotspots can I see from here? And based on which ones it can see, it can make a determination where it is by looking it up in this database, you see? Pretty cool, actually. And actually, it's a little more accurate than cell towers, depending on where you are. Like if you're in San Francisco, it's very accurate because there's Wi-Fi hotspots everywhere there. You know, if you're out in the middle of nowhere, it's not very accurate at all. But it uses more power because your Wi-Fi is more power than, as you can imagine, the cellular antenna, which has to be very low power because very small phones with small batteries need to be able to last a long time doing cell. And then finally, as you are aware, there's GPS in a lot of these devices. GPS looks at satellites streaming around the planet in geosynchronous orbit or is flying around. I don't know how many there are, something, I don't even want to throw out the number, but a couple dozen, whatever. And it's looking at them, and when it sees certain of them in the skies and it's sending messages to them and seeing what the response time is and all this business, it can calculate where you are to, you know, within a few meters, maybe even tighter than that. So you can imagine that uses quite a bit of power, okay? So that's what's going on behind this accuracy thing in core location. It also has a property called speed, which is like your speed, how fast your car is going. Notice that this is instantaneous speed, not like average speed over the last few seconds. So generally you want to consider the speed property to be kind of advisory, right? It's not something that on its own you're going to say, oh yeah, this is exactly the speed I'm going right now. It also has course. Right? So that's kind of the direction you're heading in. And again, it doesn't purport how it calculates this, but it'll use whatever it can. If it has a compass, it might use that. It might just be using where it's seeing you go, things like that. In this case, for both of these properties, if you get a negative value, that means this property is invalid. Okay? Yeah?
For the previous one, the precision.
Yeah.
So you ask the device for a certain precision?
Yeah, we're going to get to that, yeah.
Okay.
So the question is, how does this accuracy thing matter? And we're going to go over that in a second. You ask the device for location reporting at a certain accuracy. So we'll see how that goes. I just want to cover what's in correlation before we start going back or I wanted to cover what's in the object CL location before we start asking for them. And then the last one here is this property timestamp, which is a date. Timestamp, you actually are going to want to look at at certain times because you might be given locations from the system that are a little bit old, because sometimes it might cache its last known location. It might, you know, have calculated that a minute or two ago, and you might want to know up to the second, for example. So this timestamp will tell you whenever you have a location object when this was taken. There's also a bunch of methods for calculating things like the distance between two locations, right? Utility method, kind of obvious there. All right, so to answer the question, how do you get one of these CL location guys? And 99% of the time, you're going to get one from a CL location manager. Okay, so that's another object. Note right off the bat here that basically none of this works in the simulator. As you can imagine, you know, you're not moving your laptop around. It probably doesn't have GPS in it. Probably could detect where it is by Wi-Fi nodes, actually, but it doesn't do any of that. The simulator doesn't really do any of this stuff. So if you're going to write your final project and you're going to use core location, you're going to have to be on a device to test it and things like that. So just fair warning there. All right, so CL Location Manager, how does it work? Four-step thing here. One, you want to check to see what your hardware can do, because you don't want to ask your hardware to do something it can't do, okay? And we'll show you that in a second. Then you just create a CL Location Manager instance, and you set some object to be its delegate. You configure the manager for what kind of location updates you want, and I'll show you what that looks like. And then you send it a message, say, start monitoring. And then it'll start sending messages to your delegate with CL location objects. Okay? Pretty straightforward. All right, so what kinds of location monitoring am I talking about here that it can do? Well, there's accuracy-based continual updates, okay, where you specify an accuracy, and it's going to give you updates at that accuracy level on a continuous basis as things change. There's updates only when significant changes in location occur. We'll talk about that, what that means. You can actually get updates when you move into a specified region in the world. So you can specify a region in a certain way, and when you cross into that region, it will notify you. Okay? And then you can also monitor heading, what your heading is, separately from location. Okay? So those are the kinds of location monitoring that a CL Location Manager can do for you. All right, so let's talk about step one, which is checking to see what your hardware can do. So first there's this class, these are all class methods in CL Location Manager. And the first one, location services enabled, the user is actually able to go turn location services off in settings. If you go get your phone out and you go to general settings, you'll see in there somewhere, there's a thing that says turn location services off. In other words, I don't want any apps getting my GPS location or whatever. So this method will tell you whether location services are enabled at all on your device. And then there's specific questions like, is heading available? Can I get the heading from this device? Again, a device with a compass can provide heading information. There's this significant location change monitoring available. I'll tell you about what that is in a second. That's if major changes in your location get notified. And same thing with the region monitoring available and enabled, okay? So you want to call these before you're going to use one of these particular kinds of location sensing. Also, you want to, there's this string in CL Location Manager called purpose. It's just a string, you set it. And purpose is used because when your application first, when you call one of these methods or when you first try to use location services, it's going to put up an alert to the user saying, this app wants your location. Okay, this string is going to be the purpose in that alert. So if you say the purpose is so I can spy on you, the alert will come up and say, this app wants to use your location so it can spy on you, so I can spy on you. So it's important to put this string, put something sensible in there, describing to the user why you want to use these location services, because as you can imagine, it's kind of a privacy thing where, having your app know where someone is a little bit of a privacy thing, so the user has to explicitly say yes. Now, I'm not sure exactly how it works if the user says no, whether you ever get a chance again. I'm not really quite sure how they've implemented that. But if the user denies you, either that time or if it stays from previous denial, then these methods above will return no. Okay? So heading available would be no if the user said, no, I don't want my heading to be given out. Does that make sense? So that's purpose. So you want to probably set your purpose. And you can also poll the location manager. You can ask it, what's my current heading? What's my current location? We almost never do that. Usually we use the delegate and just get sent the messages as the changes, but you can ask, okay, if you really want to. All right, so the different kinds. Let's talk about accuracy-based continuous location monitoring. Okay, so this was the question that was asked. So you specify this property on Location Manager called desired accuracy. It's one of those constants I showed you on the previous slides. And you can also specify this distance filter, which is how far how much the location has to change before you're going to get notified of a new location, right? So if you're walking around and you're using it as a pedestrian, probably you want very high desired accuracy, and you want the distance filter to be pretty short, maybe 3 or 4 meters the person walks, and it gives you a new location. If you're in a car and you're just trying to map where you're driving around town, then maybe the accuracy can be a little less. It depends on whether you're trying to record what street they're going down or just general what neighborhood they're in, etc. And so obviously you want to set these to as low as you're willing to accept because it uses system resources to do this. You don't want to just crank up the desired accuracy to best and distance filter 1 meter because your battery on your phone, first of all, your phone's going to get very hot, okay? And second of all, the batteries can run out pretty quick, okay, if you're constantly trying to do GPS. Okay, so that's something to consider. A lot of people, when they first go out to write a location-based app, they're like, oh yeah, I want to know exactly where I am all the time. And they start to realize, oh, my app just totally sucks all the life out of this phone, literally. So something to think about there. All right, so again, we're still talking about continuous location-based monitoring. So you set the accuracy in the filter, the distance filter, then you send it this message, start updating location, and it'll start sending messages to your delegate. Okay? And the delegate method looks like this. Location manager did update to location from location. So it'll tell you your old CL location and the new CL location. Totally what you would expect there. As I mentioned there with the stop updating location, make sure again you turn this off when you're not using the location change. So if you have a part of your UI that brings up preferences or table view or something, stop monitoring, and then when you go back to the screen that's maybe showing a map or something like that, then go back to updating location, okay? All right, different kind of monitoring, heading monitoring. So this is, you just want to know your heading. Heading is monitored separately from location. You can be monitoring both at the same time, that's perfectly fine. But you have to set your heading filter, which is how many degrees of heading change before you're going to get an update. And then you can also adjust the heading orientation in case your app is currently in a landscape mode or something. You can make it so that the heading is 0 at the top of the screen, because normally it's 0 at the top of the device. So this is just, all this is just an offset, 90 degrees, 180 degrees, depending on the orientation of the device. Then you start updating heading, and you'll start getting delegate methods. The one here is did update heading. Okay, you don't get the old heading in this one, you only get the new heading. All right, and you're going to get this object CL heading. CL heading has the magnetic heading and the true heading, maybe. Okay, you'll only get the magnetic heading if location services are turned on. That should be. Because if it doesn't know where you are in the world, then it can't do the magnetic to true calculation, right? Because depending on where you are in the world, the difference between magnetic north and true north changes. So it needs to know where you are. So that's backwards. But so if the location services are turned off, then you can only get magnetic heading because it can't calculate true heading because it doesn't know where you are. And then heading accuracy is a property that'll tell you how accurate this heading is. So if that number is big, it means this is not very accurate. If it's small, it means this is a very accurate heading. And then, of course, CL headings also have time stamp, just like CL locations do. Okay? So heading tracking, very similar to location tracking, just a couple of different things to consider there. So heading, by the way, with the compass, a compass is magnetic. In fact, inside the phone, you've got a lot of possible interference around that might make it so it's not working. If you've ever used your compass on your iPhone, you notice that sometimes it asks you to move it in a figure-8 motion. You've ever seen that screen come up? Well, you can actually control whether that screen comes up, that little move in a figure-8 thing. By this method, Location Manager should display heading calibration. Okay, it's a delegate method. And if you say no to that, then it won't put that figure-8 thing up. But then you might start getting heading updates that say this heading is invalid because it's not configured. But if you don't do the figure-8 and you walk around a little bit and you move away from some interference, all of a sudden it could start being valid again. Okay, so also you can dismiss the heading calibration display, so you might allow it to go up. You return yes from this, but after a certain amount of time or whatever, you give up and say, okay, forget it. I'm going to dismiss this. I'm only give the person 10 seconds or whatever to do that. Okay, in both the location and the heading case, there's a delegate method did fail with error. Now, a lot of times people just ignore delegate methods that did fail with error. You're like, well, if it fails, it fails. But in this case, you actually want to look at them. The reasons for the failure sometimes they're benign, like location unknown. That's basically saying, I can't figure out where I am right now, I'm working on it. Usually you'll ignore that error and wait for it to send you another, to send you an actual update. But you might get error denied, which is the user saying, no, I don't want this application to use my, my location information. And then heading failure you might get if heading was working fine, and then all of a sudden some big interference happened, and now you're getting bad results. And so it'll send you this error that it can't get the heading anymore. Okay? So you can look in the documentation to find out what the errors are, but that's one that usually you want to take a look at. Okay, so here's another kind of monitoring. Okay, this is different. This is significant location change monitoring. Okay, so this one you don't have to set anything up. Desired accuracy, distance filter, ignored, none of that matters. Okay, because all that we're going to be tracking here is big movements. And by big movements, I mean, well, I don't want to put a number on it, but the way this seems to work is it's monitoring cell tower changes. Okay, so when your phone notices a new cell tower, it's going to probably fire off one of these notifications to you that a significant change has happened. Okay, so you can imagine, that's probably half a mile kind of movements. Okay, this is not walking around campus necessarily. Now, the more cell towers are around, I'll bet the more updates you get here. But I don't know the implementation of this, so and it gives no guarantees. All it's saying is a significant location change has occurred. Now, why is this a valuable thing? And of course, you get notified via the delegate in the same way as for the accuracy-based one. But what's interesting about this one, this works even if your application is not running. Okay, if it's not even running, and certainly also works if it's in the background. Okay, on a multitasking device, which is kind of cool. Okay, now you're only getting significant changes, but this will actually launch your application if you get a significant change and you're not running. Okay, so when you launch, we have application did finish launching with options. You let me go this whole class and no one ever asked me, what's that with options thing at the end? Okay, which is amazing. But here's one of the things that uses the with options. So if you look at that with options, it's a dictionary. And if one of the keys in that dictionary is UI application launch options location key, that means you got launched because a significant location change occurred. Okay? And then you can create a CL location manager and ask it for its location using that property location, and you'll get the location, the latest location that the system has, which is probably the location that caused this you to get launched. All right? If you're running in the background, your delegate will get this message. Normally, we haven't talked about multitasking, but all that multitasking really means is that your application, when you switch to another application, it doesn't exit. It doesn't get terminated. It just goes into the background. Okay, so it's still there. It's not really running. You're not going to get any processor time generally. You get a little bit when you first move to the background, but eventually you go dormant and nothing happens until the user clicks to wake you back up. But in this case, if you're in the background and you're dormant, you're not running, you will get woken up and your delegate method will get sent this message. Okay, the normal delegate method did update location. Okay, so this is kind of cool. But it's only for large changes. So this is, you're around town, you're in the car, you're whatever. This is not, I'm walking around Stanford trying to find the chemistry building. Okay, it's not that kind of change level. All right, so there's another thing, very, very similar, called region-based location monitoring. Okay, and this one you say start monitoring for region, CL region, which is an object, and a desired accuracy. Okay. Now again, this you can specify as much accuracy as you want, but seems to me this is probably also based on this cell tower thing. So it's only going to be able to check fairly large regions. But and here's the delegate method you get, which is did enter region, did exit region, and again runs when your application is not running. It'll fire you up. Okay, to do this. Yeah. Question. Okay, so the question is what defines a region? And let's see if I have a slide on that. Oh, yes I do. So CL regions are tracked by name because they persist, obviously, right? You have a region, you define it, and I'll talk about that in a second. Your application might quit. If your application is going to get launched when you go into that region, it needs to exist when your application is not running. So when you create a region, you create it by name. I'm not sure I actually put the initializer here, but the initializer for a region, for example, there's CL region init with circular region of radius whatever at this coordinate, name, colon, string, and you give it a name. So when you initialize it, you give it the name. Again, probably based on this same technology, this significant location change technology. There is a size limit to the region that can be monitored, and you get that if you go to CL Location Manager. There's a property maximum region monitoring distance, and that'll tell you the radius if you attempt to monitor a region larger than that, because you can imagine if you want to monitor the United States, that that's going to be weird. So it puts a limit on there. And yeah, so I guess I don't put the definition of CL region, but you can look it up in the documentation. Like I say, the one that's in there, for example, is a big circular region, defined as circular region. But it has a hit testing thing and all that, so you can look at that if you're really interested in that. Okay, so that's it for core location. Any questions about that before I move on to the map kit? Okay, all right, so what is map kit? Map kit is a set of classes for a user interface for displaying maps. Okay, these are Google Maps. Okay, so it displays a map. You can see here I've got a map view up here and displaying a map. The map has what are called annotations on it. So annotations are these little red pins. You see these red pins? The annotations are shown using a class called MKAnnotationView. The pin one is MKPinAnnotationView, which is a subclass of MKAnnotationView that shows a pin. Each annotation itself only has 3 properties: title, subtitle, and the coordinate, latitude and longitude. Okay, that's what's the only thing that's in the annotation. And then there's a process whereby an annotation view is paired up for with an annotation to display the annotation. And we'll show you how that works. Annotations can have a call out. All right, so you can see there's a call out there at Memorial Church. Thing is a call out, and you can see the parts of the call out. Here there's the title, that's Memorial Church, so that would be the annotation's title property. Front facade, that would be the annotation's subtitle property. The location, the coordinates of the annotation is obviously where the little pin is. The church, there you see the picture of the church, the thumbnail image on the left, that's its left accessory view, and the little blue button on the right, that's its right accessory view. Okay, so we're going to talk all about how we set all these things, but I just want to orient you. This is what we're talking about when we talk about annotations on a map view. Okay? All right, so how do we create a map view? You create it with alloc init, or you can drag it out from the library and interface builder. It generally, what does it do? It displays an array of objects that implement a protocol called MKAnnotation, right? And that protocol is the thing with title, subtitle, and coordinate in it. All right. Notice that the property in the map view, which gives you the list of annotations, is read-only, and we'll talk about how you update that list in a second. But here's what the MKAnnotation protocol looks like. It just has those 3 properties in it. The coordinate property is the CL location coordinate 2D. From core location, it's just latitude and longitude. Okay, really, really simple. It is okay if the title and or the subtitle is nil. That's perfectly fine. In fact, you can see that those methods are optional in the protocol. Yeah, so that annotation property is read-only. So you add annotations using methods like add annotation or add annotations, which is an array of objects that implement the MKAnnotation protocol, and you remove them using remove and remove annotation. Okay, so you can't set that property, the array of annotations, directly. If you have a lot of annotations, like, let's say you had 1,000 annotations. Well, first of all, presenting 1,000 pins on the map, even if it's a map of the entire world, probably not that meaningful to the end user. You see why? You get 1,000 pins. It's like there's going to be pins everywhere. It's not really communicating anything to them. So generally the map view is you want to keep the number of pins to a reasonable number. Also there's performance considerations here too, because you saw that each pin it has a view, possibly a left accessory view, a right accessory view. That's a lot of overhead to have all those views. You wouldn't want to have thousands of those allocated all at once. So generally what we try to do is, for example, only show the annotations that are actually visible in the map right now. And how would we do that? Well, the delegate method of the map view, one of the delegate methods is this region did change animated. And you can think of it a little bit like view did appear in a view controller. And you can ask the map view for its visible rect. And then you can ask the annotation for its coordinate and convert that to a map point. And then you can say map rect contains point. So these MK map point for a coordinate, MK map rect contains point, those are C functions that are provided by MK map view. And you can use those to kind of do hit testing. And so you find out what annotations are visible, you would add those annotations and you would remove the other annotations. Any annotation you add, it's going to get associated with an annotation view and all that stuff, so it's going to have overhead. All right? So it's pretty optimized, it appears, for adding and removing annotations. So if you scroll over in your map and a bunch of annotations go off screen, removing them out is pretty efficient. And you're going to see even some mechanism in here that's a lot like table view for doing that. So what do annotations look like on the map? We saw this a little bit earlier. By default, they look like a pin. By default, I mean if you don't associate any kind of annotation view with an annotation, it uses pin annotation as the default. But annotations in general are drawn using a subclass of MK annotation view, which is just a UI view. And you can create your own subclasses of MK annotation view if you want to draw something, funky. But the basic annotation view has some nice features in it for letting you modify it without subclassing as well. Like you can set the image, the pin, for example, you could have it be a different image or whatever. So what happens when you click on an annotation? So we see how these annotations are displayed with this MK annotation view. What happens when you click on them? Well, it depends on your MK annotation view. It gets to decide what happens. But by default, nothing will happen. But if you have this property on MK annotation view called can show callout, then it'll put that little callout that we're talking about, where the Memorial Church thing is, and it'll automatically show the title and the subtitle. Okay, so it'll just be a little box with title and subtitle only, no thumbnail image, no button disclosure. The following delegate method, when you click on an annotation, is also called, right? Did select annotation view. And you can ask that annotation view, what's the annotation? So it's essentially passing you the annotation as well. And you can do what you want here, like you could push a view controller, like if you've got a map showing in a navigation controller and someone clicks on a pin, represents some location on the map, you could push a view controller that shows more information about what's on that map. Okay? Or you might prepare the MK annotation view to display its left and right accessory views, for example. So we'll look at an example of that. Right? So when the pin is clicked on, you kind of have some choices of what you want to do. Your delegate gets notified, your map views delegate, and it can decide what it wants to do. So, oops, oh, that's not going to do far. Okay. So how do we create these annotation views, these pins, and associate them with annotations? Now, this code should look very much to you like the way we associate a table view cell with the row, with the information in a row in the table. Okay? So we have this delegate method in map view called map view view for annotation, and it takes an annotation as an argument, returns the view that's going to represent it. And we do the same thing we do in table view, which is we dequeue them, so that as annotations go in and out of the map view, we're going to reuse these annotation views. Right? So all the more reason why if we have an annotation that's not visible, we should take it out of the map view so that we can reuse its annotation view. It'll go back on the dequeue list, or on the queue. Right? So it's exactly the same. You have a string identifier when you create an annotation view, and when it gets released, it'll go back onto the queue, and then you can get them off. So exactly the same way as you do in a table view. Now, one thing that's kind of interesting here, you'll notice here I'm creating a pin annotation view to be my annotation view, and it says init with annotation. Okay, that's the designated initializer for annotation view is init with annotation : reuse identifier : but I still, after I've created it, I say aview.annotation equals annotation. Okay, a lot of people look at that and like, why? I just created this thing with the annotation. Well, the answer is I might have dequeued that thing, and then I need to set its annotation, right? So, so I could have put that in an else, but usually we don't do that. We just load up our annotation view. You know, whether we dequeued it or created it, we're going to load it up. Now, notice that I say maybe, and I even underline that, maybe load up the accessory views here, like the left and right accessory views, the picture of Stanford facade and the little blue accessory button there, disclosure button. But I say maybe because probably I don't want to actually do that here. Because that little accessory view and all that stuff that comes up in the call out, that only happens if I actually click on that pin. Right? If I click on the annotation, then I get that thing. So I'm going to wait until my delegate gets called when I click on that pin, as I showed you on the last page, and then I'm going to spend the resources to create an image view or an UI image or download something from Flickr or whatever to create that, okay? So a lot of times what I'll do is just reset them here to be nil, and then wait till someone clicks, and then I'll load them up. Does that make sense? And now I have set the annotation, so it does know the title and subtitle, but it's a performance thing here where I don't want to load up, especially if I have 100 pins or 200 pins, which would be a lot. I don't want to create all the views and UI images for all their thumbnails. That would just be a huge amount of work that I want to avoid if possible. Okay, so let's talk about MK annotation view, these views that you create. Its properties, it obviously has a property which is the annotation that the view is drawing. It also has a property image. That is not the little picture of Mem Chu on the left. That's the pin. Okay, that's the image of that's going to show where the pin would go. Left call-out accessory view, that's the view that you'd probably set maybe to an image view, and that would be your Stanford Church picture. Right call-out accessory view, a lot of times that's a disclosure button, that little round blue button. It also has enabled, whether it's enabled or not, center offset. That's like the pin. Where the pin is stuck into the ground, that's where the actual latitude and longitude is. So the center offset lets you pick where in your image of your pin or whatever you're showing where the head of the pin is, basically. And then also draggable. These pins, you can pick them up and move them if the annotation that's associated with this view implements set coordinate also. Because MK annotation, that protocol, only has read-only coordinate. But if it also implements set coordinate, it's just going to use introspection to see, then it'll let you pick the things up and drag it as long as this is draggable as yes. Does that make sense? Okay, so if you set one of your call-out accessories, the left call-out accessory view or the right call-out accessory view, if you set it to be a UI control, like a UI button, for example, then when it gets tapped on, you'll get this message sent to your delegate. So you don't have to set up target action for your right call-out accessory view, which is a UI button. You can just implement this delegate method. It'll get called every time you tap on it. Does that make sense? So it's just kind of a convenience for you, so you don't have to set all that target action up. You just use this. And it is very common to do this. Accessory view.right callout accessory view equals UI button, button with type, UI button type detail disclosure. That's the blue little round button. Okay, very common to do that. Okay, so I told you that when I have that DQ and all that I'm not going to really load up my annotation view then because I don't want to spend all the resources. So here's an example of doing all that loading up in a did select annotation view. Okay, so the did select annotation view, delegate method of my map view. When I click on the pin, it gets called. And it gets called before the little call out comes up. All right, so here's an opportunity for me. In this case, I'm checking to see if my left callout accessory view is a UI image view, which I would have had to set up in that other method. And if it is, then I'm going to create a downloader and go off and download the image from somewhere, Flickr or something. And then I'm going to dispatch back to the main queue to set the image to be that image. Now, this code, for those of you who are working on the current assignment, you'll notice this code's got a little bit of a problem, which is if I'm dequeuing and reusing, I might end up sending the image queue, the image view's image to some other reused cell. Okay, so this is, you can look at this code as kind of conceptual to go back and set the image. But the point here is I could set things up so that when the pin is clicked on, that's when I'm going to go do some work. You know, anything that's going to use resources to load up that little callout box. Now, the callout box is going to immediately come up without the image, and then later, once this thread is done running, the image is going to appear. Okay? Now, this is probably more okay to do than it is in the table view case because there's only one image view up at a time anyway, right? And the chances that you clicked on the same one and it reused that same cell to show that image, pretty low. Okay? So this might be code. It's like got a corner case, but it's also missing a curly brace, it looks like at the bottom there. Okay, overlays. I'm not really going to talk about overlays here because I want to leave time to do the demo of all this stuff. But an overlay is essentially something you draw, okay, that it's a path, basically a CG path, that's tied in geosynchronously, all right, to the map. So as the map scrolls around and zooms in, your overlay stays linked to it. So you could show a bus route, for example, something like that. That's what overlays are for. They work almost exactly the same as annotations. It's just that instead of being a point, they're this path that gets drawn. So I'm not going to really go into this too much. It has a bounding rect, so it can do hit testing, whether you clicked on the overlay. It's associated with an overlay, just like an annotation is. There's a method view for overlay. There's not the same dequeue mechanism though. And then the main thing is when you have an overlay view, an MK overlay view, which is like an MK annotation view for overlays, you have to implement this method draw map rect zoom scale in context. And this is kind of like draw rect, not quite though, because notice that you're passed in the context here to draw with, whereas in draw rect you use the current context by calling that UI graphics get current context thing. So here you're actually given the context. You might actually be asked to do this in a thread. The core graphic stuff is thread safe, so that's okay. You can draw in the context, but you wouldn't want to be calling UI kit things that are not thread safe in this implementation of this. All right, but most of the stuff you're doing in this draw rect, CG path, do this, CG rect, do that, you know, those kind of methods. So. You obviously, when you're drawing, you might want to be able to convert from map points to points in your view, and you do that with these methods that are in MK overlay view that you inherit. So you can find that. All right, so that's it for overlays. You can look that up if you want to do an overlay for your final project or whatever. The map can display street level, or it can display, you know, Google Earth, or a hybrid of those two. And you set that with this property right here. You can also show the user's current location on the map. If you say show user location yes, then you'll have, I think it might be purple, possibly, pin that will show the current location as the user walks around the map. And you can also restrict a little bit the user's interaction with the map. You can keep them from scrolling or zooming. Like if you just want to show a certain part of the Earth and you don't want them looking at other places, you can stop them from doing that. And you can also specify what region on Earth you want the map to show. Okay, you just have this property region, which you set to be an MK coordinate region, which is a struct that has a latitude and longitude of the center of the region, and then a delta of how many degrees of latitude and how many degrees of longitude to extend from that center. And it's going to make it fit in the space. Okay? And you can either just set the property directly, or you can call this set region animated, and then it'll, you know, scroll, it'll show you, it'll animate to make that region appear on the map. And you can also just specify the center point, and it'll keep the same zoom level of the map and just move to make that center be the center. Okay, so it's like scrolling. It's basically a scrolling mechanism. Yeah, there's methods from converting points from world coordinates, latitude and longitude, to points in the view. You don't use these quite as much now that they have the overlay views, but still might be some interest. And then your delegate also can get notified when the map is getting loaded. So these are Google Earth, remember, so downloading these things, especially if you only have 3G, could take a while. So you get notified when it started loading something and when it's completely finished downloading whatever's currently displayed. So as you scroll around or zoom in and out, it's going to start loading again, and it might take a while for it to finish loading. I mean, if you're doing it in the simulator, this is all happening instantly because you're all here at this very fast Stanford internet here, and you're on a laptop, not a small device, and so this is all happening fast. But when you put it on a device, you're going to notice, oh, it takes a while to download this stuff, these images. And you can also get fail if, like the network, you have a network failure trying to download this stuff, you'll get notified with that as well. As I mentioned on the previous slides, really, there's a bunch of C functions, maybe a couple dozen, for converting from all kinds of different coordinate systems here, view coordinate systems to map coordinate systems to real coordinate systems in the real world, so check those out too. All right, so I rushed through the last part of that because I want to show the demo. Hopefully a lot of this will make a lot more sense when you see me actually do it. So what I'm going to do here is I'm going to take Shutterbug that we had from last time, and Shutterbug's first table view is a table of photographers. And what I'm going to do is have a button on that page that you click that flips the table view over and shows a map and shows where in the world that photographer's photos came from. We'll just pick a representative photo for each photographer, and we're going to show where it is. And then we can click on it, and we'll show a little call out. And then when we click on the call out, it'll show the photos for that photographer. Make sense? So that's what we're going to do. Okay, so let's get started. Any questions before I start that? Nope. Okay. So I'm starting with the Shutterbug code we had last time. And the first thing I want to do here is put some instance variables in for my map and my table view. So here is my table view controller here for photographers. So this is kind of an interesting design point here, as I'm going to actually make these IB outlets, even though I'm not going to use an interface builder file to build my user interface here of the map and the table view, but I want to make it so that it's possible for someone, if in the future they wanted to modify this app to use an interface builder file for their table view, they could. So there's no reason not to make this IB outlet thing, so that's what I'm going to do. So I have MK map view. That's my map view, and I better import map kit. Okay, map kit is the framework that has it in there. And then I'm also going to have an outlet for my table view. Now you might say, wait a second, this is a table view controller, right? We inherit from core data table view controller, which inherits from UI table view controller. But something interesting about that is UI table view controller actually does not have an instance variable for the table view. Okay? It has a property for the table view, but the way it implements that is it returns self.view. So if you create a subclass of core data table view or of UI table view controller, and you want to have your top level view, your self.view, not be the table view controller, you have to store a pointer to the table view controller yourself. So that's what I'm going to do, because my top level view is just going to be a generic view, and it's going to have two subviews, the table view and the map view, and I'm going to switch between them. All right? So I have to do that. So I'm going to create a property here, and actually I'm going to make it public. Why not? IB action, oops. I retain here. Retain. IB outlet. MK map view. Okay, and table view, I already have that property. I inherit that from UI table view controller, so I don't need to make a property for that. One thing I'm going to go ahead and do here while I'm in here is make sure I set myself to be a map view delegate, because obviously I'm going to have to implement some of these map view delegate methods to make this whole thing work. So let's go over here. I'm going to, in my implementation, I'm going to synthesize my map view and table view. And let's see, oops, switch back there. Okay, I'll start using this thing, I guess. Okay, what else? Anything else? Oh, yeah, if you're going to use MapKit, it's not part of UIKit or Core Foundation or whatever. So you have to go down here to Frameworks, right? See Frameworks in here? And if you right-click, you can say Add Existing Framework. And then if you look through the list, you see all these many frameworks, and MapKit is one of them. So add. So if you don't do that, when you run your program, build your program, you're going to get link errors because you're not going to be including that framework. Okay, next what I'm going to do up here is I'm going to implement map views getter. And I'm just going to lazily create that thing. So if not map view, then map view equals mk map view alloc init with, what is it? It's just init with frame. So we're not putting, I'm just creating this lazily. I'm not putting it in a view hierarchy, so I'll just do UI screen, main screen, application frame as my thing, and then return map view. Okay. Don't need to do table view because I'm just going to return the thing, but my instance variable table view, and I already synthesized that. But let's talk about how I'm going to build my UI here, because I got an interesting thing going on here. I'm inheriting load view from UI table view controller, and it's setting my self.view to be my table view. Do y'all understand that UI table view controller does that for you? Right? How else are you going to get that table view? It creates it for you, and it sets it to be self.view. So that's not quite what I want. So in my view did load, I am going to do something a little different. First of all, I'm going to, if my table view is not set, if no one's set that instance variable, and if my self.view is kind of UI table view, which it should be if I've just inherited it, then I'm actually going to set my table view to be self.view. Okay? So all I'm doing here is just grabbing my table view from self.view if I got it by inheriting it. Okay? Hopefully you understand that. So now that I've had my table view, my map view is lazily instantiated. All I need to do is build my view hierarchy. Very simple. I'm just going to self.view equals. I'm just going to create a generic UI view. This is going to be the view that contains my map view and my table view. So alloc init with frame. Again, I'm not putting self.view in the view hierarchy here, so I can pick whatever I want. I like to use this main screen application frame as my default frame. Also, I have to be careful here. Probably want to auto-release this. Release. Okay, because I'm assigning it to self.view. And so that's going to retain it. And so I don't want it, I want it to be properly memory managed there. So I've got my self.view. So now let's just add our table view and our map view as subviews of that self.view. I am adding those views now to a view hierarchy, so I better set their frame. Remember, every time you add a view to a view hierarchy, you have to set its frame. So in both cases, the table view and the map, I want them to fill my self.view entirely. I want them to be the whole thing. So table view.frame equals self.views bounds. Okay, so I'm going to set my frame of my table view to fill the whole thing, and then I'm just going to say self.view add subview self.table view. Okay, and I'm going to do the exact same thing for the map view. And then I'm going to add the map view. Okay? So now I've built a generic view. It's got these two views underneath it. I'm going to switch back and forth. Now, how am I going to switch back and forth? I'm going to use that thing UI views hidden Remember the hidden property of UI view? If I say hidden equals yes, it hides that view. Still in the view hierarchy, but it doesn't draw, it doesn't accept any events, it's totally hidden. So that's the way I'm going to do it. So I'm going to start off with the map view hidden. Okay, so my table view will be showing map view is hidden. And the last thing I want to do is set my map views delegate to be myself. Okay, because we're going to be doing some map view things. Obviously, I want my map views delegate to do the right thing. Okay, so how am I going to build a UI to have this button that switches back and forth between these two things? Well, what I'm going to do is in my view.did_load, I'm going to say self.navigationItem.rightBarButtonItem. Okay, so I'm going to have, if I'm in a navigation controller, it's going to be the right side bar button item. And I'm just going to say UI bar button item alloc init with title. I'm going to have the title be a constant here. I'm going to call it map button title, and we'll define that in a second. And the style, I'm going to do UI bar button style. Which style do I like here? Actually, yeah. I don't remember what type. I think I just did bar button item style. Yeah. Style bordered. Oops. Ugh. All the keys are in a slightly different spot. Style bordered. Okay. Target is self. And action, let's have it be selector toggle map. All right, and I'm going to auto release this as well, since I'm assigning it there. Sorry? Yeah, I probably should do that. View.did_load is an interesting one because it doesn't actually say in the documentation that you have to do it, that you have to call super.did_load. It probably doesn't hurt, but it's probably not necessary either. Okay, now view will appear, and view did appear. Those you do have to call super. It says in the documentation you must call super. View.did_load, for some reason, it doesn't say that. I'm not really sure exactly why that is. Okay, so what else we got here? UI bar button item style. Okay. All right, so see I've created this right bar button item. It's going to start with the word map on it. I'm actually going to have it change to the word list when we go back to the table view. So we'll call that list. List. So now I need that method that I defined right here, that selector right here, toggle map. Okay, so I'm going to implement that. Pretty straightforward. Void toggle map. So all the toggle map is going to do is if the map view is currently hidden, then we're going to make the map view not be hidden. And we're going to make the table view be hidden. Okay? I'm also going to set my right bar button's title to be the list button title in that case. And then same thing here, if it's the other way around, we want to do the opposite. So this is yes, this is no, and this is map. All right, so if we typed all this in properly and put all our curly braces there, hopefully this should work. So let's try this. Okay, so here we've got our table view, right? And if we click map, it switches over to the map. Okay, so here's our Google Maps, and we can zoom in and out. We don't have any annotations though, right? So the next thing we want to do is do annotations. All right, so how are we going to do this annotation thing? We need an object somewhere that implements MK annotation, right? Which is the coordinate, title, and subtitle thing. Well, I've already got an object that pretty much represents the thing I want to put on this map, which is these photographers. So I'm just going to make my photographer class implement MK annotation. Does that make sense? And then I can just get a list of them and put them right on here. All right, so let's do that. So to make my photographer class implement that, I'm going to go back to my data model here, and I'm going to add some properties to photo, first of all, because I need to know where the photos were taken. So I'm going to add an attribute latitude to photos. latitude, which will be a double. And then I'm going to add another attribute here, which is longitude, which is also a double. And while I'm in here, I'm also going to add a string, which is we won't get to this today. Maybe we'll do this next time. Thumbnail URL, which is a string. Okay, so that's the same thing as image URL, but it's just for the thumbnail. So now we got a fixed photo so that it implements these. I could do the copy, special copy and all that stuff, but I'm just going to type it here. Well, actually, no, let's do the copy, actually. Let's go back here. Let's pick our new things. I'm going to go up here to Design, Data Model, Copy Declarations. Go back here. Right here, I'm going to paste these in. I don't need this empty interface thing. Okay, so there's that. And then let's go back over here. Select these again. Let's go Design. Hopefully you all recognize what we're doing here. The implementations. Go to photo.m. Click down here, paste. Get rid of this whole if zero thing. We don't need any of that. Okay. So now we've updated our photo to do it. The only other thing here is in photo, we need to set those properties when we do the flicker fetch. So let's do that. So that's just photo.latitude equals flicker data object for key. It happens to be called latitude. And then photo.longitude equals flicker data object for key longitude. And then I also had that thumbnail URL, and that's flicker fetcher URL string for flicker data. Oops. Yes, KR data. And the format I'm going to use is the same one you probably used for your app, which is format square. Okay? So now I've changed my photo, changed the model, changed the download. Photo is good. Now all I'm going to do is go to the photographer over here, and I'm going to make it implement MK annotation. So I'm going to put here MK annotation. I'm going to have to import MapKit. Okay, I'm also going to import, oh, no, I didn't do that, okay. So how am I going to do this? What are the properties? One property is CL since it's read-only even. CL location coordinate 2D coordinate, that's one of the methods. Another method, which is optional, but I'm going to do, is read-only NS string title. Okay, so those are the two methods in MK annotation, one required, one optional, that I'm going to implement. So let's go over to the photographer and implement those. So how am I going to implement those? Well, the coordinate one, CL location coordinate 2D, I'm going to implement, actually I'm going to implement that using a representative photo. So I'm just going to grab a random photo that this photographer took and use its coordinate as this photographer's coordinate. So I'm going to say photo star representative photo equals, let's go ahead and implement, let's put a method representative photo on ourselves. So let's just put that, let's even make that a public method. How about that? Or even a property. Photo read only. Okay. So how would we implement that? Very easy. Photo star representative photo. We'll just say return our photos relationship any object. So there's a good use of NS sets any object. This we could use dot notation, but we won't. So then CL location coordinate 2D location, location dot latitude equals the representative photos latitude, and location dot longitude equals the representative photos longitude. Return the location. And then we'll implement the title. I'm just going to return the photographer's name. So that's going to be our title of our annotation. Okay, so before we run this, we are going to want to go back to the simulator here and delete Shutterbug. And you know why that is, because we've changed our model, right? So we want to make sure that we start with a fresh database. So let's see if this works. So what we got here, oh, sorry, photos should be self.photos. And then what else we got here? Oh, yes, these are double values. So I need to take these and do double value. Okay, what else? Let's look at all our warnings here. What do we got? Coordinate, and it don't have a matching atomic. Oh, okay. So yeah, we haven't really talked about atomic. Non-atomic has to do with threading. If a method is non-atomic, it means you can't guarantee if you call it from multiple threads that it's going to work. So we haven't really talked about what that implication is, but most of the methods in the UI kit are non-atomic, but you already know that you can't call them multiple threads anyway. So let's try that. See what happens here. Okay, so now we haven't actually added the annotations to the map, but I just want to make sure we didn't break anything, and we didn't. Everything seems to work. So now all we need to do is get a list of photographers that's in our table and put them in the map. Okay, well, that's actually very simple to do, and I'm going to do it right here. Okay, this is if map view is hidden and we're making it not hidden. I'm going to say if the map view annotations is nil, if the map view annotation is nil, in other words, if we haven't added any annotations, then I'm going to add my array of annotations. And the way I'm going to get it is I'm going to use the same fetch request that my table is using to go fetch my photographers. So I'm going to create a little NSFetchResults controller, which is self-fetch-results controller, just because that's a long name. And then I'm just going to say self.mapView add annotations, and I have to give it an array, right? So I'm going to say frc.managedObjectContext, execute fetch request, frc's fetch request. We will ignore errors. And also, I better retain this because that is auto-released. Okay, and close our curly brace. Okay, so that's it. This should work. Okay, let's go see what happens here. All right, so we have our table. Click to our map. There it is. Okay, so as we go around the Earth here, we can see all of our things. Now, when we click on one, all we get is the title. Okay, because we haven't done anything to associate an annotation view that has anything interesting in there with our default pins. Okay, so last thing we're going to do today in the last 5 minutes here is I'm actually going to put a write accessory view into the annotation view for these things that is a disclosure button, UI button, disclosure button. Yeah, question? Sorry?
Who will release this since you retained it?
Right, so the question is this array of pin things, array of annotations, who releases it? And the answer is when the map view gets released, it'll release its annotations. Well, that's a good question. Yeah, actually, you're right. It should. So we do not need to retain there. Very good catch. Okay, because add annotations will retain this array. So we don't need that. Okay, so let's go ahead and associate the annotation view. So remember that the way we associate annotation views is with this delegate method. And so let's just pop that in here. Put it right here. And it's called MK annotation view, map view. Okay, map view, sender, view for annotation. And it takes an object that implements MK annotation. Okay? Now, Normally here we would do the DQ. We're running out of time, so I'm not going to do the DQ. I'm going to create one for each annotation. Actually, not a problem here because I add all of my photographers as annotations. So I'm not going to get any reuse anyway, okay, because they're all in there. Now, if I had something smarter that was only showing the visible ones, then I would definitely want to be DQing. But here, I'm not going to do that. So I'm just going to say MK annotation view equals MK annotation view alloc init with annotation, and we'll pass the annotation. The reuse identifier doesn't matter because I'm not doing reuse. You know, I'm going to save this, but not necessary really because I did it in my init. The only thing else I need to do here is I want to create that right callout accessory view. So I'm going to say aview.write callout accessory view equals UI button with type UI button type detail disclosure. Okay, so that is going to, let's go ahead and return a view. Okay, so let's see what that does. We're not quite done, but let's see what that does. Yeah, okay, I'll put the retain back in for now, and we'll answer that question later if that's really necessary, because it doesn't seem like it should be required, but let's put it back in. That's not our problem here. Hold on, we got a problem. Oh, I know what the problem is, sorry. This wants to be a pin annotation view. Okay, we want a particular kind of annotation. Before we weren't specifying what annotation view, so we were getting pin by default. In this case, if we're going to specify it, we need to specify that we want a pin. So now when we click on these on a pin, one more thing. Sorry. We need to make sure that we can show callout equals yes, okay, because we do want our annotation views when we click on them to show the callout. So let's do that. Okay, so now we have the callout, but we have the little blue button, okay? But if I click on the blue button, nothing happens, okay? And that's because we need to use this little magic delegate method that gets called when you touch a control that's an accessory view. So let's do that, and that is called void map view. What's that thing called again? It's called callout access. Oh, sorry, annotation view. Okay, annotation view. Callout accessory control tapped. Thank you, Xcode, for typing that for me. Control star control. Okay. So the implementation of this is trivial. This is a one-liner because we already have a method inside of our table view that when we click on a row that represents a photographer, it shows all the things, and that is self managed object selected aview.annotation. Okay. Now you might say, wait a second, managed object selected takes an NS managed object star, and aview.annotation is an ID angle bracket MK annotation. Yes, but the way Objective-C does its static typing here, that aview.annotation, it's still an ID, all right? So IDs can be passed into static typed. So that's why this is not complaining. See, I'm compiling, no complaints. You could argue that's kind of questionable, but the compiler looks at the MK annotation as an additional typing mechanism which it'll match up, but it doesn't have to, the ID part is still an ID. Okay, so let's look at that and see if this works. All right, so we have our thing here. This is still working, right? I can still click in the table, and now hopefully I should be able to click in the map. Okay, works exactly the same. All right, it's just that we're clicking on maps items instead. Okay? All right? So that's pretty much what I wanted to do today. In our next lecture, we will, I'm going to work on this demo a little bit more. I'm going to put the thumbnail in there. Okay, and the reason I want to put the thumbnail in there is a little bit of review of what you're supposed to be doing for your homework, which is due tomorrow. So you'll hopefully have all turned it in by then. And it's not exactly, so if you haven't, I'm not going to be giving it all away. But I also want to show you just a little bit how we can be lazy about going and doing the fetch. And then also on Thursday, I'm going to try and cover some miscellaneous topics that you might well want to use for your final project. So kind of grab bag day on Thursday. And that's pretty much it. So I will see you then.
For more, please visit us at stanford.edu.